it is given that root node is present at depth 1 and we have to find the number of locations required for representing for sequential representation of right skewed binary tree of depth k. In ideal case, complete binary tree representation doesn't waste any space. But in the worst case, a skew tree of k of level k will require 2 power k minus 1 locations, of which only k will be occupied, of which only k locations will be occupied. So here correct option is option B. This question, 3 numbers are given and we have to find the number of different AVL trees that can be formed by those numbers such that they can be inserted in any order. First of all, we need to know, in order to solve this problem, we need to know what is an AVL tree. An AVL tree is nothing but a binary search tree in which balance factor of each and every node is plus or minus 1. So here balance factor is nothing but height of left subtree minus height of right subtree. So this should be equal to plus or minus 1. So AVL tree is nothing but binary search tree in which every node has balance factor as plus or minus 1. So here given numbers are 5, 6, 7. So here we can have let us construct different binary search trees with this given numbers. So here this is one possibility, 5, this is one possibility, 5, 6 and 7. In binary search tree, right side should be greater than, the elements which are greater than the root should be in the right subtree. So this is one possibility and this is another possibility and one more, this is one possibility. So here this balance factor, here balance factor of 5 is minus 2. Why? Because balance factor is left subtree, height of left subtree minus height of right subtree. So here minus 2. So this cannot be an AVL tree. So we cannot take this. This is same is the case with this one also. Here balance factor of 7 is 2. So here we cannot take this one also. So this here balance factor is 0, here 0 and here also 0. So we can take this as binary tree. So here the number of binary trees, the number of different AVL trees with the nodes, with the numbers 5, 6, 7 is nothing but 1. So here correct option is option A. In this question, Newton-Raphson method is used to find the root of the equation 3 into x power 1 by 3 is equal to 0 and initial approximation x0 is given as 0.1. In Newton-Raphson method, iteration formula is given by xn plus 1 is equal to xn minus f of xn by f dash of xn. So here xn is equal to xn minus f of xn is 3 into xn whole power 1 by 3. Xn whole power 1 by 3 by f dash of xn, 3 into x, and f dash of xn is xn power minus 2 by 3. So if we simplify this, we will be getting xn plus 1 as minus 2 into xn, and here initial approximation x0 is given as 0.1. So let us calculate x1. x1 is equal to minus 2 into x0. Minus 2 into x0 is given as 0.1. So x1 will become minus 0.2 and x2 will become minus into minus plus 0.2 into 2 minus plus 0.4 and x3 is nothing but minus 2 into x2. So here minus 2 into 0.4 is nothing but minus 0.8 and x4 will become minus 2 into x3 minus 2 into, so minus into minus plus 1.6. So here if we observe these values, we can say that this method fails to converge and the value oscillates. So here correct option is option C. This question, two sets are given and we have to find the symmetric difference of the given sets. So here symmetric difference of the sets S and T is represented by S delta T and it is nothing but S minus T union T minus S. So here S minus T is nothing but 1, 2, 3 union T minus S is nothing but T minus S is nothing but 6, 7, 8. So union of these two sets is nothing but 1, 2, 3, 6, 7, 8. So here which is option? So here the correct option is option D.